All right, so today this presentation is going to be about graphing trig functions. So we're going to start with sine and cosine, and just like how we graph normal or other functions, so linear, exponential, we normally fill out these t-charts, where on the left side is the input and the f of x is that output. So with trig functions, we're going to pick points from the unit circle. Um, the unit circle is that thing where the radius is 1. And if you look at the last video, we have these quadrantal angles. So we're going to look at those points. So this is 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to look at those 5 angles to graph sine and cosine. So we want to evaluate sine at these 5 coordinates, and we also want to evaluate cosine at these 5 coordinates. Well, we know sine is always going to be the y coordinate at that point. So at 0, the y coordinate is just 0. So sine of 0, meaning f of 0 equals sine of 0, which is just 0. So we're going to put that here. And cosine of 0 would just be the x coordinate. So cosine is the x coordinate at 0. And the x coordinate at 0 is just 1. So we can do it that way, or of course you can always use this table. It's up to you. You know, 0, 1, 2, 4, 4, 3, 2, 1, 0. Either way is fine. It's up to you. But once I'm just going to use the unit circle. So the coordinate here is negative 1, 0, 0, negative 1. So at pi over 2, we look at the y coordinate, which is just 1. At pi, we look at the y coordinate, which is just 0, negative 1, and then back to 0. So those are our 5 evaluated coordinates for sine, and same thing for cosine. Pi over 2, we look at the x coordinate. So if we just look at the x coordinates, 1, 0, negative 1, 0, 1. All right. All right, so now we want to plot these points. So we have to scale this graph. Well, if these are our y coordinates, or the points that go up and down, our max point is 1, our minimum point is negative 1. So it's not going to go any higher or lower than 1. So we can just put, 1, 2, negative 1, negative 2. So that's just scaling the graph. We could do the same thing here. And our x coordinates are in terms of pi. So again, pi is just a number. We could just, pi is 3.14. We could just put 1, 2, 3 and just kind of estimate. Or if we want it to be exact, we can scale the graph to the exact x coordinates that we have. So we can do 0, pi over 2, pi, 3 pi over 2, and 2 pi. So we can do it just like that. The graph does not have to go 1, 2, 3, 4, or 5. The graph can be scaled however you like it. Whatever scale helps you best visualize what the graph is trying to do. Or say. All right, so for sine, so when x is 0, and I'm going to do sine in red, when x is 0, f of x, when x is 0, f of x equals 0. When f is pi over 2, so we go to the right, pi over 2, we go up 1. The next one, we go to the right pi, we go up or down 0. We go to the right 3 pi over 2, we go down 1, even though I kind of wrote over that. And then back at 0. So our graph, when we connect these points, will look something like this. Notice that I didn't draw a straight line. I didn't do this. I made it curved. All right, so now let's look at cosine. So cosine, when x is 0, so that means we went left or right 0 units, we go up 1. The next point is we go to the right pi over 2, we go up or down 0. And if we just keep plotting these points, we'll get something that looks like this. Again, we are not drawing a straight line. We are curving this line. Sinusoidal functions, meaning trig functions, sine and cosine, are curved. They're not vertical lines. And it doesn't have to be perfect, but this is typically how it will look. So that's sine and cosine. Now we're going to start talking about different variations of sine and cosine, but you should know these two at least. These are called the parent functions. So sine kind of looks like a S, cosine kind of looks like a V. That's one way that I remember it. Sine, and if sine has not been manipulated, it starts at 0. If cosine has not been manipulated, it starts at 1. So these are just patterns to kind of help you remember what the parent functions look like, where they start, just certain properties of them.